Hello dear students, hope you are all doing well. I'm back again with another video lesson. In the previous lesson, we studied the interference of light when the light passes through the two slits. The bright fringe and the dark fringe occur on the screen, and also we solved all questions related with the interference of light. In section 2, we will talk about the diffraction of light when the light hits the sharp edge, and when the light passes through the small opening, the light is going to be diffracted. So this diffraction also can occur the dark fringe and the bright fringe. So the dark fringe and the bright fringe also appeared on the screen by the diffraction of the light. For example, we have this barrier and we have many portions of light. This is screen. See that? This is screen. Okay. If you have some portion of the light, the portion of the light is moving like this. Okay. But when the light hits this sharp edge or the small open, okay, what happened to the light? The light does not move in the straight, and instead they're going to be diffracted. Okay, so what is this? This is the diffraction of the light. And also we have gratings. When the light passes through the gratings has many lines. Okay, so this light also can be diffracted. So that by the diffraction, as a result of the diffraction, the dark fringe and the bright fringe also occur. So exactly we have the same equation that we use in the interference of light in section 1. For the bright fringe, d sine theta is equal to m lambda. Okay, and for bright fringe, for dark fringe, this is for what? Bright fringe. But for dark fringe, d sine theta is equal to what? M plus 1 over 2 lambda. This is for what? This is for dark fringe. Okay. If in the question number of line is given, you can find the distance between the slits by using this relation. Distance between slits is equal to what? 1 over number of line. Okay, and the number of line also is equal to 1 over d. The relation between number of line and d is inversely proportional. More line has less distance. Less line has more distance. For example, in this diffraction grating, how many lines is there? 1, 2, 3, 4. So what is this? This is the distance between the lines, or distance between the slits. Okay, but if you look this grating that has many lines, this is grating number 1, this is grating number 2. Which diffraction grating has more number of lines? Absolutely the second one. But which one has more distance, the distance between the two slits? Absolutely the first one. Okay, look, the distance between these two slits is less, is very small, while the distance between the slits in the first grating is large. Okay, so that is why the relation between distance between the slit and the number of slits is what? Inversely proportional. Okay, inversely. Look at this sample problem 7b about the diffraction of light. Listen carefully. Look at the question. Sample problem 7b, monochromatic light from a helium neon laser, lambda wavelength is equal to what? 632.8 nanometer. So you have to convert 2 meter, nanometer, 2 meter times 10 to the power negative 9. 632.8 times 10 to the power negative 9 meter. Okay. Shines at a right angle to the surface of the diffraction grating. Okay, perpendicular diffraction grating. What we have? We have a diffraction grating, a device that it goes to diffract the light. That contains what? 1,050,500 lines per meter. Okay. 150,500 line per centimeter. 150,500 line per centimeter. What is this? This is number of line per meter. Number of line is equal to what? 150, 500 lines per meter. It means that in 1 meter we have this number of lines. Okay, so you can convert this number of line to distance directly. Okay, d is equal to what? 1 over number of line, 1 divided 150, 500 is equal to 6.64 times 10 to the power negative 6 meter. What is this? This is the distance between each slits, okay, between the two slits. Okay. Find the angles at which, what is unknown? Angle. Angle is unknown, at which one would observe the first order and second order. First order, m is equal to 1, theta is equal to 1 when m is equal to 1. Theta is equal to what? When m is equal to 2. For the first time, when m is equal to 1, we have to find the angle, okay, of the angle of diffraction, because the question described the bright, okay, first order and second order maxima. Maxima, it means that bright. Okay, so that is why we have to use the equation of the bright fringe. The equation of bright fringe, theta is equal to what when m is equal to 1? D sine theta m lambda. What is unknown? Theta. Whenever theta is unknown, you have to take out the sign. This sign becomes sine inverse, and this d, it goes down. M lambda remain here. Just rearrange, okay? When theta is unknown, you have to rearrange the equation like this. Sine inverse m lambda over d. Now we have everything, just replace, okay? M, first order, 1. Lambda was given, but we converted 632.8 times 10 to the power negative 9 divided by d. We didn't have d, guys. The distance between the slits not given, but we found by number of line per centimeter per meter. Okay, d is equal to what? 6.64 times 10 to the power negative 6. So theta is equal to what? Is equal to 5.465 degree. When does theta, when m is equal to what? For the first bright, okay? For first bright, theta is equal to this number. But for the second bright, as the number or the number increases, the angle of diffraction also must be increases, because theta with m is directly proportional. Theta with m is directly proportional at constant wavelength and distance. Okay, in this question, wavelength and distance is constant. Only m changes. More m, more theta. Let's check. When m is equal to 2, theta is equal to what? Theta is equal to sine inverse. Instead of 1, m lambda over d. Yalla guys. Sine inverse m, but this time is equal to 2 because we have to find for the second order, the second time. Lambda is still the same. 632.8 times 10 to the power negative 9. It means lambda is constant. Distance also is constant. Time is 10 to the power negative 6. Theta for order number, second order number, theta is equal to 10.98. Okay, so in this way you can determine the angle of diffraction for each of first order and second order. Very good question and very easy question. Look, this is first order and this is second order. Which one has more angle? Absolutely, the second one has more angle. Okay, practice 7b, question 1. A diffraction grating with 5,000 line per centimeter. Guys, listen carefully and pay close attention. 5 times 10 to the power 3 lines in what? In centimeter. But the distance between the two slits in the equation of the bright and dark must be in meter. Okay, number of line is equal to 5,000 line per centimeter. Whenever the number of line is given, you can convert to distance or you can find distance directly. Okay, d is equal to what? Guys, look, d is equal to 1 over number of lines, 1 over 5,000, okay, which is equal to 1 divided by 5, 0.2 times 10 to the power negative 3 or 2 times 10 to the power negative 4 what? Centimeter. What is this? This is the distance in centimeter. Why? Why D is centimeter? Because number of line was given in line per centimeter. That is why this D is centimeter. Now D is equal to what? D is equal to 2 times 10 to the power negative 4 centimeter. It's not allowed to solving question with a centimeter for the distance. You have to convert to SI unit. SI unit of distance is meter, not centimeter. You have to convert to what? Meter. How? Multiply small to large, multiply 10 to the power negative 2. Convert centimeter to meter times 10 to the power negative 2. But meter to centimeter, you have to multiply 10 to the power positive 2. Okay? So D is equal to what? 2 times 10 to the power negative 6 meter. What is this? This is D. Now we have to use this D in the equation because the SI unit of distance is meter, not centimeter. This is D. It's used to examine the sodium spectrum. Calculate angular separation. What do you mean by angular separation? It means delta theta is unknown. Okay? Angular separation, delta theta is unknown. Between what? Now I'm going to tell you. Angular separation of the two closely spaced yellow lines, sodium, lambda 1, lambda 2. How many wavelengths do we have? Two wavelengths. Lambda 1 is equal to 588.995 times 10 power negative 9 meter, and lambda 2 is equal to, there is a little difference, the second lambda is bigger, 589.592 times 10 to the power negative 1. So absolutely lambda 2 is bigger than lambda 1 at constant order number. Theta 2 is bigger, it should be bigger than theta 1 in each of the first three orders. First three orders, it means that when find delta theta when m is equal to what? 1. Find delta theta when m is equal to what? 1. Okay, guys, look. At constant m, when the order number is constant, when lambda 2 is bigger than lambda 1, theta 2 also bigger than theta 1. So what is the relation between wavelength and theta? Is directly proportional, but at constant what? At constant m. Guys, I'm going to repeat, please, once again. Wavelength with the angular and the angle of diffraction is directly proportional with theta. But when m is constant, at the same order number, for m is equal to 1, which one has more angle, lambda 1 or lambda 2? Absolutely lambda 2. Why? Because it has more wavelength. Okay? When m is equal to 1, d sine theta is equal to m lambda. So theta is equal to what? Sine inverse m lambda over d, which is equal to sine inverse m is equal to 1. Lambda 1, we have to use lambda 1 to determine theta 1. 588.995 times 10 power negative 9 over d. We didn't have, but we found 2 times 10 to the power negative 6. By calculator, theta 1 is equal to what? Theta 1 is equal to 17.13 degree. What is this? This is the angle for the first wavelength, which is equal to 17.13. Okay? For this m1, for the same, for another wavelength, for the second wavelength, same m, look. Theta 2 is equal to what? M still is equal to 1, yes. But lambda is changing, okay? For the second angle of diffraction, theta is equal to what? Sine inverse m, which lambda? The second lambda over d. Sine inverse m still 1, yes. Lambda 2 is equal to 589.592 times 10 power negative 9 over 2 times 10 to the power negative 6. You can see that theta 2 is equal to what? Theta 2 is equal to 17 0.15. There is a little difference between theta 1 and theta 2. Why? Because the wavelengths are very close to each other. That is why this separation is not too much. It's very small, okay? So now delta theta is equal to what? And separation, look, calculate the angular separation. It is that delta theta between these two wavelengths. Delta theta is equal to what? Theta 2 minus theta 1. 17.15 minus 17.13 is equal to 0.02. 0.02 degree. This is delta theta for when m is equal to 1. So you have to do the same process. You have to do the same thing for m is equal to 2 and m is equal to 3. So you can try by yourself and you can solve this question. And already the answer was mentioned here, okay? Delta theta is equal to 0.04 for m is equal to 2 is equal to 0.11 for m is equal to 3, okay? Question 2, practice 7b. The question says a diffraction grating with 4,525 line per centimeter. Again, number of line was given in line per centimeter. Number of line is equal to 4,525 line per centimeter. You can convert into distance. D is equal to what? 1 over number of lines. 1 divided 4,525 is equal to 2.21 times 10 to the power negative 4 centimeter. So you have to convert the centimeter to meter. Now D is equal to what? 2.21 times 10 to the power negative 2 times 10 to the power negative 4, which is equal to 10 to the power negative 6. Okay? 10 to the power what? Negative 6. You have to convert this centimeter to what? To meter. Multiply 10 power what? Negative 2. Negative 2 with negative 4, it's going to be negative 6 meter. Now D is ready. Okay? Illuminated by direct sunlight, the first order solar spectrum. Solar spectrum, it means bright fringe. It means what? The bright fringe. First order, M is equal to what? M is equal to 1. On a white screen hanging on a wall opposite the grating. A. At what angle does the first order maximum? First order maximum, it means bright. For blue light. For what? For blue light. With a wavelength 422 nanometer appear. At what angle? It means that theta is unknown. Theta unknown for what? For the blue light. Blue light, the wavelength of blue light is equal to what? Is equal to 422 nanometer to meter times 10 to the power negative 9 meter. So how can you determine theta for m is equal to 1? Theta is equal to sine inverse m lambda over d. Look, sine inverse. Do we have m? Yes. First order, 1. Lambda, yeah. 422 times 10 to the power negative 9. Divided by distance, we didn't have, guys. We didn't have distance between the slits in this grating, but we found. And instead of the distance between the two slits, between the slits and between the gratings, the number of the gratings are given. Number of lines are given in the diffraction grating. So we try to convert to the distance between the gratings, which was equal to 2.21 times 10 to the power negative 6. Calculator, theta is equal to what? Theta for the blue is equal to 11 degree. Okay, this is angle for the angle that appeared, the angle between the first order and the central order of the blue light. B, at what angle does the first order maximum for red? Look, this is the angle for what? For blue. When m is equal to what? M is equal to 1. So we have to find theta, but for what? For red. M still is equal to 1, yes. Lambda of red is equal to lambda blue, no. Which one has more wavelength? Absolutely, red. The red color has more wavelength than the blue color. Roy GB. Red has the longest wavelength but lowest frequency, while the blue, its wavelength is less than the wavelength of the red. The wavelength of the red is 655 times 10 to the power negative 9 meters. So guys, in this question, theta is equal to what? Sine inverse m lambda over d. Guys, look, m is constant, d also constant. M is constant. Look, for the blue light also we used m1. Okay, m is constant, d also constant. The diffraction grating and the distance between the grating does not change by changing the source of the light. Okay, the distance between the grating changes by changing the diffraction grating. Okay, so m and d is constant. What is relation between theta and lambda? Absolutely is directly proportional. More wavelength has more angle of diffraction. So because the wavelength of red bigger than wavelength of blue, so that is why the theta of red is bigger than theta blue, but at constant order number and distance between the gratings, please. Okay, keep in your mind, at constant m and d, theta and wavelength is directly proportional. Okay, now theta is equal to what? Sine inverse m still 1, yes, but wavelength 655 times 10 to the power negative 9 over 2.21 times 10 to the power negative 6. This is the distance between the gratings. Theta is equal to what for the red one? 17.2 degrees. So which one is bigger? Absolutely the theta of red, and this is the theta of blue. Okay, question 3, practice 7b. A grating with 1555 line per centimeter. Again, the number of line is given in lines per centimeter. Number of lines is equal to 1555 lines per what? Centimeter. Convert to distance. D is equal to what? 1 over number of lines. 1 over 1555, which is equal to 6.43 times 10 to the power negative 4 centimeter. Convert to meter, multiply 10 power negative 2. So D is equal to what? 6.43 times 10 to the power negative 6 meter. This is the distance between the lines in this grating. Illuminated with the light of the wavelength. Wavelength is given 565 times 10 to the power negative 9 meter. Nanometer to meter negative 9. What is the highest order number? Guys, listen carefully. This question is very good question. What is the highest order number? The highest order, whenever the question says the highest order number, theta is equal to what? Is equal to 90. Theta is equal to what? Is equal to 90. And this order can never be seen, cannot be observed, cannot be observed. The bright fringe that located at this angle at 90 degrees can never be observed. Be careful, okay? So what do you mean by theta is equal to 90 that can be observed with this grating? Okay, what is the highest order number that can be observed with this grating except at 90? So we have to find the m, okay? Find the order number. In this case, guys, look, this is diffraction grating. This is the diffraction gratings. And this is the source of the light. I think, yeah, we have converging lens. Yeah, this is the light that hits the diffraction gratings, okay? The central bright, M0. M is equal to what? 0. This is M1, M2, M3. So, but we don't know how many orders, how many bright fringes do we have. But I know this fringe exactly located here. Why? Because this is angle 0, okay? This angle is 0. Guys, look. This is 0, okay? The central maximum theta is 0 here. But the highest order located at this point, okay? At this position. Theta is equal to what? 90. Can we see this order? No. we cannot see this order, okay? But I can see the others. Okay? This order cannot be seen, be careful, when theta is equal to 90. Now, we have to find the order number. The order number is equal to what? Look, this is very good question, be careful, as many students are struggling with this question, but I'm going to make it easy. Guys, did you get? Once again, listen carefully. When the light passes through the converging lens, and this converging lens makes the light parallel and hits directly to the diffraction grating. When the light passes through the diffraction grating, the central bright located here at the center of the screen, okay, of the diffraction grating or spectrometer, this is spectrometer. M is equal to 0, theta 0. When M is equal to 0, theta is equal to what? 0. The question says, what is the highest number? What is the highest order number? The highest order number, you have to use 90, theta 90 for this order. But this order cannot be observed. Cannot be observed because located exactly at the 90 degree with respect to the central. Okay? Now, M is equal to what? What is M? D sine theta is equal to M lambda. M is equal to what? D sine theta over lambda. D, we didn't have, but we found 6.43 times 10 to the power negative 6 times sine what? Sine 90. Sine what? 90. And over wavelength, wavelength was given, 565 times 10 to the power negative 9. M is equal to what? M is equal to 11. Okay, so this is M is equal to 11. The highest order maximum is equal to what? 11. Look, this is M0, M1, 2, 3, 4, 5, 6, 7, 8. It should be 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This one cannot be seen, be careful. Okay? With the central, we have 11 bright fringe. If the question says how many bright fringes can be seen or can be observed, 11. M is equal to what? M is equal to 11. Okay? This is the highest order number of this question, of this wavelength. Okay? Question 4, practice 7b. A diffraction grating is calibrated, but guys, look, I forgot to tell you this. M here is equal to 0, but here M is equal to what? 11. How many bright fringes can be observed? 11. But this one cannot be observed. But with the 0 one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And M is equal to what? M is equal to 11. Question 4. A diffraction grating is calibrated by using 546.1 nanometer. Wavelength is equal to 546.1 times 10 to the power negative 9 meter. Line of mercury vapor. The first order maximum, M is equal to 1. The first order maximum is found at this angle. Theta is equal to what? 21.2 degree. Calculate the number of lines per centimeter on this grating. Guys, this is very good question. Be careful. What is unknown? Number of line per centimeter, not per meter. What is unknown? Number of lines is unknown per centimeter. To determine number of lines, you have to make a plan. So the plan of this question is determine number of line. Number of lines is equal to what? 1 over D. But this D, it should be in centimeter. This D, it should be what? Centimeter. Why? Because the question said find number of line per centimeter. Number of line per centimeter, okay? Do we have D? No, we have to find D. D sine theta is equal to M lambda. D is equal to what? D is equal to M lambda over sine theta. When you find D in this equation, the result of D is meter. But you have to convert to centimeter, okay? M first order, lambda was given 10 to the power negative 9 over sine 21.2, I think, yeah. D is equal to what? My calculator. D, I got 1.51 times 10 to the power negative 6 meter. Can I put this D here into this equation? No. Why? Because this D is meter, but we have to convert to centimeter to determine number of line per centimeter. Can I put this one? No. You have to convert to what? Centimeter. How can you convert to centimeter? 10 to the power positive to large to small. Positive power. D is equal to 1.51 times 10 to the power negative 4 centimeter. Now we can put this D here. 1 divided by 1.51 times 10 to the power negative 4 is equal to 6.62 times 10 power 3 lines. Lines per what? Per centimeter. But if the question says find number of line per meter, don't convert this meter to centimeter. You can put directly this distance in meter, okay? Question 15 in review and assess. If the light with the wavelength 353 nanometer, wavelength is equal to 353 times 10 to the power negative 9 meter, is passed through the diffraction grating with 795 slits per centimeter. Slits also it means lines, okay? Lines. How many number of lines per centimeter do we have? 795. This is number of lines is equal to 795 lines per centimeter. Find D. D is equal to what? 1 over this number, which is equal to 1.26. 1.26 times 10 to the power negative 3 centimeter. Convert to meter. Multiply 10 to the power negative 2. D is equal to 1.26 times 10 to the power negative 5 meter. This is D. Find angle at which one would observe the second order maxima. Second order maxima, M is equal to 2. Find angle. It's very easy. D sine theta, M lambda. Theta is equal to what? Sine inverse M lambda over D. Do we have M order number? Yes, second order 2. Wavelength was given. 10 to the power negative 9 over distance. We didn't have. As usual, we found 26 times 10 to the power negative 5. And the theta of the second order that appeared on the screen is equal to 3.21 degree with respect to the central bright fringe. This is question 15. Now, question 16 in review and assess. This question, by attaching a diffraction grating spectroscope to an astronomical telescope, one can measure the spectral lines from a star and determine the star's chemical composition. Okay? Assume the grating has 3,661 lines per centimeter. Number of lines, 3,661 lines per centimeter. D is equal to what? 1 over this number. Okay? Which is equal to 2.73 times 10 to the power negative 4 centimeter. Convert to meter, multiply 10 power negative 2. D is equal to 2.73 times 10 to the power negative 6 meter. Okay? If the wavelength of the star's light are, what is this? This is wavelength. A. Branch A, wavelength is equal to 478.5 times 10 to the power negative 9 meter. And the second wavelength, this is lambda 1. Lambda 2 is equal to 647.4 times 10 to the power negative 9. And lambda 3 is equal to 694.4 times 10 to the power negative 9. So which one is largest wavelength? This one. Sorry. This one has the largest wavelength, so that is why it has
theta 3 bigger than theta 2 and bigger than theta 1. What are the angles at which the first order spectral lines occur? What are the angles? It means that theta 1 is equal to what? Theta 2 is equal to what? Theta 3 is equal to what? Theta 1 belongs lambda 1. Theta 2 belongs lambda 2. Theta 3 belongs lambda 3. For theta 1, sine inverse m, which lambda? The first one, lambda 1, over what? Over d. But for the second one, sine inverse m, which lambda? Lambda 2 over d. M and d constant, yes. Sine inverse m lambda 3 over d. Sine inverse m is equal to what? Lambda 1 for 78.5 10 power negative 9 over 2.73 times 10 power negative 6. Lambda theta 1 is equal to 1009 degree. Theta 2 sine inverse m still constant 1. Lambda 2 is changed 647.4 times 10 power negative 9 over 2.73 times 10 power negative 6, which is equal to 13.71 degree. For the third one, sine inverse still m1 lambda 3 gets more and more, 694.4 times 10 power negative 9 over 2.73 times 10 power negative 6. Now theta number 3 is equal to what? Is equal to 14.77 degree. So in this way you can find the theta for each of the wavelength, because m is constant, d is constant. More wavelength has more angle, okay? So because lambda 3 bigger than lambda 2 and lambda 2 bigger than lambda 1, theta is the same thing. Theta 3 is bigger than theta 2, bigger than theta 1, but at constant what? Constant what? M and d. Only at constant m and d, theta with wavelength is directly proportional. So you have to do the same thing for m2. Do the same thing, absolutely, you will get the more number of angle. Question 20. The 546.1 nanometer, this is wavelength. This is wavelength. In a mercury is measured at an angle. Theta is equal to 81 degree. Okay. In the third order spectrum, m is equal to 3. Third spectrum, it means at the bright line. About diffraction grating, calculate the number of lines per centimeter. Number of lines is unknown per centimeter. Okay. So to determine number of lines per centimeter, write down the equation of number of lines is equal to 1 over d. This d should be meter or centimeter? Absolutely centimeter. Why? Because the question says find number of lines per centimeter. Now we have to try to find d. D is equal to what? D is equal to m lambda over sine theta. Okay? M3, wavelength 546.1 times 10 power negative 9. Sine 81. D is equal to what? D is equal to 1.66 times 10 to the power negative 6 meter. Convert to centimeter. 10 power positive 2. Now is equal to 1 over 1.66 times 10 to the power negative 4, which is equal to 6,025 lines per centimeter. Lines per what? Per centimeter. The last question. Visible light from an incandescent light bulb ranges from 40 nanometer. This question also is a very good question. You know that the visible light is a polychromatic light. It has several colors, several wavelengths, from red 700 nanometer to violet 400 nanometer. This one is what? This is violet. This is red. Okay, this is the range of the white light. When this light is focused on diffraction grating, when this light is focused on this diffraction grating in spectrometer. Look, the source is white light. Okay, and also we have a converging lens here to make the light parallel to the diffraction grating. This is the diffraction grating. It has number of lines, okay, and the white light strikes the diffraction gratings. The central order, it becomes white also, okay. The central bright always has the same color of the source. What is the color of the source? White light, okay, and the central also is white. This is M0. What is this? M0 is white. But because the source is a white light and the white light is a polychromatic light, when passes through the diffraction grating, the spectrum appeared on the screen, or the spectrum produced on the screen, because the light is polychromatic. When we say the spectrum, it means that the first line is violet from red, and this one is red, Roy GB. After red, orange, we have orange. This is M1, guys. After orange, we have yellow, okay. Roy, G, Roy, red, orange, yellow, green, okay, and Roy G, beef, yeah, blue, indigo. Assume that this is indigo, but actually this is not indigo. And violet. The last one is what? Violet. So which one has the shortest angular separation or angle of diffraction? The violet. The violet has the shortest angle, okay, because its wavelength is 2 less. This is the theta of the violet. The theta of red has maximum angle of diffraction. Why? Because it has more wavelength. So the diffraction grating, one of the advantage of the spectrometer to determine and to measure the wavelength of the colors. Okay, guys, look. This is the first order. Okay, this is M1. What is this? This is M1. The first spectrum, consider it to be M1. Okay, the entire first order spectrum is seen. So we can see the entire first order, and sorry, it should be the figure. Sorry, there is something I made a mistake here. Now I'm gonna fix it. Look, guys, the entire first order can be seen. So from red, so the red, it should be start from here. Okay, red. Okay, orange. Yellow, green, blue, indigo. Assume that this is indigo. Actually, it's not. And the violet. The last one is what? Violet. The entire first order can be seen. The entire first order M1 can be seen. But none of the second order spectrum is seen. What do you mean by this statement? When the question says none of the second order spectrum is seen, it means that the second spectrum is located after this 90 degree. This angle is what? 90. Okay, so the second spectrum is located here from violet. Okay, from what? From the violet. After violet, indigo. Indigo. After indigo, we have blue. After blue is green. Okay, and after green, yellow, orange, red. Guys, we cannot see the second spectrum. The entire second spectrum when m is equal to 2 started from violet. Started from where? From violet. So when the light is located, when the light is at the violet, angle is equal to what? Theta. Angle is equal to 90 degree. For which color? For violet. For which color angle is 90 degree violet? Can we see behind this 90 degree? No, it's impossible. We cannot see the spectrum and the bright fringe when located at 90 degree or behind 90 degree. Also, we cannot see 91, 92, above 90. From 90 and above, we cannot see and we cannot observe the spectrum. So that is why in this question we have to use m is equal to what? 2. When m is equal to 2, which wavelength can be used? The wavelength of violet, 400. 400. We cannot use for the red one because the red can be seen. Time is 10 to the power negative 19 meter. And at which angle the violet is appeared in the second spectrum, in the second order? At which angle the violet observed for the second spectrum? At 90. Can we see this violet? No, because angle is 90. Okay. Now, what is unknown? D is unknown. What is the distance of this diffraction grating? D is unknown. How can you determine D? It's very easy. D sine theta is equal to m lambda. D is equal to what? M lambda over sine theta. M2 lambda 400 times 10 to the power negative 9 over sine 90, which is equal to 1. D is equal to 2 times 400, 800, and 8 times 10 to the power negative 7 meter. What is this? This is D. Okay? Guys, we solved all questions in the diffraction grating section 2, chapter 7. Now we're going to solve the questions of the section review. Light passes through the diffraction grating with 3,550 lines per centimeter and forms the first order. M is equal to 1 at this angle, theta. Okay? What is the wavelength of this light? Question 1. Number of line is equal to 3,550 lines per centimeter. First order, m is equal to 1. Angle, theta is equal to what? 1207 degree. A, what is unknown? Wavelength. What is the wavelength of this light? Wavelength, guys, look. Wavelength is equal to d sine theta m lambda. Lambda is equal to what? D sine theta over m. Do we have D? No, but we can find it. D 1 over 3,550, which is equal to 2.8 times 10 to the power negative 4 times 10 power negative 2 to convert to meter. 2.8 times 10 power negative 6 meter. Lambda is equal to what? 2.8 times 10 power negative 6 times sine 12.07 over m is equal to 1. Lambda is equal to what? For branch A is equal to 5.85 times 10 to the power negative 7 meter. This is the wavelength for this light. Question, branch B, at what angle will the second maximum appear? At what angle, in branch B, at what angle the second order? Look at this question, guys. In this question, the wavelength doesn't change when order number changes. For the branch A, m is equal to what? 1. When m is equal to 1, angle is equal to what? 12. But when m is equal to 2, angle, it should be what? It should be more than 12. At constant wavelength. The wavelength doesn't change. We can use the same wavelength. Look, theta is equal to what? Sine inverse m lambda over d. In this question, d lambda is constant. D also constant. But m change it from m1 to m2. When m increases, what happened to the angle? Angle of diffraction also increases at constant wavelength and distance between the gratings. Sine inverse m is 2. Wavelength still the same. 5.85 times 10 power negative 7 over the distance between the gratings 2.8 times 10 to the power negative 6. Theta is equal to, it should be more than, 24.7, exactly is equal to twice of the theta at M1. Describe the change in width of the central maxima. Describe what? The width of the central maxima, it means that theta, of a single slit diffraction pattern as the width of the slit is made smaller. As what? The width of the slits is made smaller. It means that the D gets less when D gets less because theta is equal to sine inverse m lambda over D, and theta is inversely proportional. Describe the change in width of the central maximum of the single slit when the width of the slit is made smaller. It means that D is decreased, theta it must be increased. The width of the central maximum increases. What happened to the slit? Increases. Okay. Which object would produce the most distinct diffraction pattern? An apple, a pencil lead, or a human hair? Absolutely the human hair, because its size is close to the wavelength of the visible light. As the object is thin and thin, its diffraction becomes more and more. This is a very question, be careful. Question 4, would orange light or blue light produce a wider diffraction pattern, more theta? Absolutely the orange. Orange and blue. Why? Because orange light, longer wavelength, our diffraction. Okay? We finished this section. Hope you get benefit from my lesson. Keep up your best doing. Inshallah, in the next lesson, we will finish chapter 7. Have a good time. Thank you for listening.